Okay, 1D. Water is pumped into the tank. When the height of the water is 5 feet, so water is coming into the tank. We have our tank, however it looks, and water is coming into the tank. When the height of the water is 5 feet, so at that instant, the water is still going up. The height will be going up at a rate, keyword is rate, 0.26 feet per minute. I need to write that down. So I wrote dHdt is 0.26 feet per minute. Using the model from part C. Okay, the model is that formula F. So we're still supposed to use that formula F from part C. So you would be using this, which you can see on your paper because your paper is laid out with all the problems in front of you. Using that model, find the rate at which the volume of the water is changing with respect to time when the height is 5 feet, and we're supposed to indicate units. So we have one rate, and they're asking us to find a related rate. So we definitely use the DREAD process. So my Danica's chart with the amounts and the rate. They gave me dHdt. They want me to find dVdt at a given instant, the instant when h equals 5. So this would be at h equal 5. Okay, so now we need to, I've read the problem, I've got all the rates written down. Now I need to find an equation that uses the amounts. Oops, wrong thing. An equation which uses the amounts, right there. So I need an equation that has an h and a v in the equation. Well, that's the equation I used in part C. The volume is found by taking the area of every cross-section and multiplying by the thickness of the cross-section. If we do that from 0 to whatever h we pick, that will give us the volume of the object at any height. So this is our formula that uses the amounts. It uses h and it uses v. So following the DREAD process, once I have my formula that uses the amounts, I now need to differentiate that formula with respect to time. So I've got to find dVdt. That means I'm finding the derivative of this integral. So that's where we use this formula. The formula for finding the derivative of an integral is right here on the golden notes. So we take our formula inside the integral, that's called the integrand, and we plug in the upper limit right here. Then we take the derivative of the upper limit. We're going to do it in terms of time, so that'll be a dt. So I'm going to go back and follow that formula. So here's my integrand, and wherever there's a variable in the integrand, that variable gets replaced by the upper limit. And then because we're taking the derivative of v with respect to time, I then must multiply by the dh over dt of that upper limit. So if you have done all of that correctly, and you get this red box, you get 2 points. All that's left to do now is say we want to calculate dVdt at the exact moment when the height is 0.5. So we just plug in 5 for the height. We don't have to work anything out. Just plug it in like you see here and stop. Make sure you indicate units. That's part of the 1 point. So 3 points total for part 1D.